Koutou katoa, ko Ingarani me Piripini te whakapaparanga mai, ko Leicester me Bristol te whenua tupu, ko Tamaki Makaurau te kāinga, he Industry Research Liaison Manager o New Zealand Food Safety Science and Research Centre, ko Kaila Archer toku ingoa, tēnā koutou katoa. Welcome to our first food seminar spotlight series of 2025. Today I'm delighted to have Emeritus Professor Andy Shilton from Novolab. Andy is the inventor of a supercritical UV technology used for liquid disinfection. He is a fellow of the Institute of Professional Engineers of New Zealand and has over 25 years of experience ranging from design and build of full-scale pollution control systems to mechanistic environmental research. Andy worked as a consultant engineer in New Zealand and the UK before returning to Massey University, where he holds the position of Emeritus Professor of Environmental Engineering. Novolabs is a spin-out company from Massey Ventures, which is the commercialization arm of Massey University. So if you have any questions for Andy, I'll be hosting a Q&A at the end of his presentation, so please put your questions into the Q&A function at the bottom. And we're also looking for topics that you would like to hear about, so do feel free to drop me or Mike or Dan an email on any food adjacent subjects that you'd like to see seminars on. So for now, I'll hand over to Andy and Matt, and they can do all the exciting talking.
Look, thank you so much for that introduction. And so first of all, just like to introduce Dr. Matt Sells, who's the CEO here at Novolabs, and lurking in the ether out there is Dr. Russell Wilson, who's one of our directors who might join us for a few questions towards the end, if that's appropriate. But basically, what I'd like to do today is just tell you a little bit about our company or our technology, take you into the sort of world of UV and disinfection, and some of its sort of possible limitations with existing technology, which leads nicely into why we're sitting here as a new company with what we think is a very big global potential. We'll cover some case studies, and in particular we just start maybe raising some questions about possibilities related to particularly food and beverages at the end. And just to kind of just to be absolutely upfront, so as it was said before, although I've worked a lot with everyone in food out there at Massey University, my background is actually in environmental engineering. And with Novolabs, that's the area that me and Matt thought, well, that's where we've got to get started. So given that, so we do like water treatment. Water treatment is our main customer right now. But given that, I think most of the equipment that we've already sold has gone out into the food industry, not for treating internally, but rather to ensure compliance at the end of the line before it goes back into the receiving environment. So UV light it's a very simple, easy way of doing disinfection, and I'm sure you've probably heard about it, but in a nutshell, light is emitted from lamps. Just they look like normal sort of neon lamps like you'd find in an office building, except the light coming out is a very particular wavelength at 254 nanometers. And that's what's called germicidal UV. It's very effective at kind of screwing up the whole roadmap for making new bacteria. So it messes with DNA structure there. And when that happens, if the cells replicate, well, they're basically effectively dead because you've got two non-viable cells. The stuff, we make big bits of gear like you see on the screen there, but the way we make it is a totally different approach and a whole new configuration to existing UV systems. And so I think kind of like a good starting point is just to step back a little bit. And obviously with industry you guys are working in, you'll be very familiar with things like pasteurization. As I said before, we come in more particularly selling, at this stage we've been focused on selling into the water industry. And yeah, so but it doesn't really matter. From the treatment of liquids, there's only a number of certain number of options. There's a range of different chemicals. I suppose you can chuck ozone into that category, but chlorine, for example. And every one of these has pros and cons, but particularly when you have liquids which have a high organic content, things like chlorine become very problematic. So The other options like membranes, so again for water treatment, that's good. It doesn't get so good as the water gets dirtier. They do clog up very easily. They are quite expensive. They even need chemicals again for cleaning. But there are options out there, and of course there's high pressure processing, which I'll touch on very quickly later on. And there's different options, but perhaps, if you can, and certainly for the case in the water industry, if you can treat by simply putting a UV lamp and shine some light onto the liquid or into the liquid, certainly in the water industry, that's the #1 go-to because it's cheap, simple, easy to use compared to all other options. So if you can use UV for disinfection, you definitely want to, if it's viable. So just looking at what I'm going to call today legacy UV, because that's what the existing technology is. It's essentially just lamps, and you can see the system on the right-hand side there, where they take a whole rack of these lamps. They'll put them in quartz sleeve to protect the, basically it's a insulation from the water there, and they'll just put it down. You can put it into a channel of water, kind of like one lamp there, one lamp there, and that spacing, while I'm doing that, with that spacing, that becomes quite important later on. Or you can have it kind of like a tube, as you see on the left-hand side. So if you're in a factory, that's a very good solution. Just you pump straight through, and all the tubes are poking in from the end there. So that's kind of what the whole industry looks like right now. And that's a big industry. The UV market it's around about $8 billion in sales each year. And the thing which is really interesting, and you'll hear this from a quote from somebody in the industry later on, is that there hasn't been a lot of movement from the technology they were using decades ago. So it's essentially, standardized UV lamp, and they take those, put in that quartz sleeve, and as I show on the left-hand side there, that photo we saw before, they'll submerge it into liquid. But that has very common limitations, that everybody's essentially building the same thing for liquid treatment out there, and then they all have those same limitations. And probably the most important one today is going to be this clarity limitation. So the easiest way of explaining this is that UV light is absolutely fantastic at killing microbes, and it's absolutely terrible at trying to penetrate through liquid. So the loss of light intensity is exponential as it tries to push its way into fluids. And again, that idea that the intensity drops off at an exponential rate is a super important part of this, what I want to talk to you about. So that liquid that you see in the little vial there, even though it looks pretty clear, that would be considered way out of range of existing, even multi-billion-dollar UV supplies couldn't treat that. The other hassle too is that you see at the bottom the bottom little circle, there's some poor guy, he's got a whole lot of these tubes, and he has to go through, extract each one of those quartz sleeve and clean it. And the reason for that is that when you put a light bulb into a little quartz sleeve and put it in liquid, it gets quite hot. And if you have any sort of dissolved or other organic solids or minerals, they tend to start caking on. And I think, Matt, you were saying in the meat industry, there was a site you visited and they were cleaning. So you can also have automatic wiper systems, which help.
Even with was daily phosphoric acid washes, just to get rid of the scale buildup that hooks onto those lamps.
Yeah, so that's again a major issue. And we certainly know from staff and operators who work in this industry, it's one of their least favourite jobs. Now, that's where we have a total different approach. We don't put our lamps into liquids. So there are things that you can do to get UV to work. You can pre-treat and try and make it clean enough to work properly, or make clarity better, or probably not a great, really applicable to the food and beverage market. Or other options that you can wind up for power. But remember that even if you wind up your power to try and push more in, you're always fighting against an exponential loss. And at a certain limit, for even the big players, say they'll just walk away. So that's because of the sort of idea of clarity and ability to penetrate liquids is quite important. I wanted to slip this extra slide in, Matt, where we really define what UVT is. And you'll hear me talk about UVT later when I talk about case studies, because it's easy to talk about low clarity. It's not quite right. So, and you can see there, I often say to people like Sprite, for example, if I took a, Sprite lemonade, if I took a glass of flat Sprite and you tried to get light, UVC light through it, you'd struggle. You'd find that it's actually really hard. And that's because there's so many dissolved solids in there, or, liquids with a little bit of coffee in it. Again, very hard to treat because these compounds just start sucking up the UV light, which means that it's not getting through to all the microbes, which is what you need to get the kill. So the legacy systems, those sort of systems like this, if you're buying one of those or looking on their website, they're going to, whoopsie, we're jumping with our slides. They're going to be saying, ideally they'd like about a 60 to 100% UVT. Now what UVT means, it's basically how much UV light can get through 1 centimetre, and there's a standard lab measurement. So if you had like a beaker in the bottom left, which is crystal clear drinking water, we'd benchmark off that, and we'd say that's 100% UVT. But if you had something which was like mud over on the right-hand side, no light would get through, it would be a 0% UVT. And of course, in reality, what we're dealing with is everything in between. So with those legacy systems, I said on the last slide that you could just pump more power in, but even then they tend to go down to about 30, 40%, Matt. I think you've talked to guys from the industry, and they just kind of had a walk away value, didn't they?
Yeah, like if it's under 30%, they just walk away at that point because they just can't get enough power into the system to really get disinfection.
And actually, we might circle back to that because I have a slide later on about what Mrs. Bearson said and what actually the guys at Xylem said. So we might come back to that. It's kind of softball they were tossing you. But when we get into like industrial wastewaters or food processing wastewaters, very typically less than 20%. You'd be lucky to be anywhere near that. Liquid foods and beverages or other processed liquids, generally it's all less than 10% or even less than 1%. So it can be basically totally out of the range of normal UV. And that's why we wanted to talk to you to say, well, now we have something where we can go down into those ranges. And so just first slide to introduce our technology. We call it supercritical UV. And the reason for that, and there's a few, don't get confused because there are a few times that supercritical gets used in engineering literature, but what this refers to is flow hydraulics down an open channel, and flow can go down a channel in one of two forms, subcritical or supercritical, and I don't want to bore you with that, but kind of think about, water in a river and it's moving slowly along, comes to a dam and goes down the spillway of the dam. And you might be familiar with what that looks like. That it shoots down, like I took the family to Benmore Dam a few years ago, and you can see it shooting down there. It's very thin and very fast. And there's a whole lot of technical definitions around Froude number and so forth. But that's basically what we do. We set up one of these, it's also called a shooting flow, very thin and very fast. And do you remember what I was saying? Is that the problem with UV light is it's terrible at penetrating through liquids. In fact, it's an exponential loss of intensity as it tries to get through liquids. But we've just made it very, very thin. And we've managed to then maintain a high throughput by triggering this so it's kind of a fairly rare flow. And that's our patent. So we've got patents basically on the combination of radiation or UV light into supercritical flow. So triggering a supercritical flow and applying that light to it. And we've got that patented in countries that represent 70% of the world's GDP. So you can see Mark, our chief engineer there, opening up one of what we call a module. And we've taken a lot of kind of design aspects because we had to redesign this from scratch. It's nothing like normal UV. Our lamps aren't submerged in a big tank of water or channel, and they're not, or in a big pipe. As you can see in the bottom picture, and we'll have a better look at that in a video shortly, the lamps actually, and there's reflection going on there, but lamps, there's actually 2 lamps up at the top, and you can see in the top photo Mark standing there with his hand on the lid, and that just folds down like a hatchback of a car, and all the power of the lights are up in there. They do not even come close to the liquid. So they're not submerged, which means we don't get all those nasty scaling issues. And then, as you can see in the bottom photo where it is closed and in operation, the UV lights radiating down, the liquid is very thin, and if you're a microbe in there, you're in a lot of trouble because there's really nowhere to hide. And through this design, we've actually had some quite remarkable results. Things which we've had, in global industry players, wanting to talk to us about. Still a relatively young company, as was mentioned before. We spun out of Massey University, but we do have a whole bunch of sales behind us now. We've got about 33 modules, I think, now sold in various combinations. Our first one's just about to go over to Australia, probably any day now. And in total, we've had over now 2 billion with a B litres of liquid successfully disinfected out in commercial applications. So again, just to emphasize this, there's the old legacy idea on the left with your lamps in a tube, and you have some sort of spacing, maybe 100 mils apart, and then it radiates out from there. So it's got to penetrate a lot of liquid, whereas on the right, it's a sort of schematic of how our system works. The lamps are up the top. They're basically, it's like a sunbed, those old tanning beds where it just radiates straight down. There's reflectors to focus it down. And the liquid at the bottom is actually only a matter of a few millimeters deep, going very, very fast, but very thin. So here we are. What we'll do is, I just thought it'd be nice for you to see one of our systems from the inside starting up. So as you can see, what you're looking at there is a camera which is inside the channel, which Mark has open on the left. And you can see the lamps will come on, the flow will start, and basically the flow will slowly, we do what's called a soft start, just to make sure that it stays smooth. And I don't know how well you can see with the video quality, but the velocity just gets higher and higher and higher until it's whipping through that system in less than a second. So that works, that's a different way of doing it. But the key thing is it comes with a whole range of customers. So we've got customers, obviously, in municipal wastewater treatment, which is classic environmental engineering, but more predominantly in food processing. So fruit and beverage, very popular with meat processors. And we've even had a system, I'll show you a photo of that later, of where we put it on treating milk. And that was actually for a guy who wanted to know more about, or he kind of wanted for animal health when he was feeding calves. So I'll chat about that. But without boring you with all the detail here, essentially, maybe the top middle one is the most important one. As I said before, for existing legacy systems, even if you power it up and put lots of power in, they tend to walk away from about 30 to 40% UVT. That's what I was talking about before. So UVT, they can't go further or lower clarity than that. And as you can see, we can go down 100 times lower in a single pass. We have client sites out there operating at around about 0.3% UVT, which is just totally unbelievable at first when we presented that into the market for existing operators. They were just blown away. But I'll give you case studies. We've got all the data, we've got all the proof that works extremely well. And because of that, the last unit we shipped, actually, that was an example of top left-hand, just about cost. They were facing a $5 million cost to try and disinfect a very low clarity liquid. They came to us. we basically could offer him a solution which was 2.5 times or 250% cheaper. So, you know, and it's showing us here at about 2 million. That actually isn't even the price of our unit. That was less. That includes all for pumps and pipes and everything else. Fully installed on site. And that's literally one of New Zealand's biggest meatworks. But it's easy for me to say all this stuff. It's jolly good. It does amazing stuff. But I think it's more convincing when you hear what other people say. And that's what I mentioned this before about Bearson. So Mr. Bearson was the guy many, many years ago who first started thinking about using UV light as a disinfectant in commercial applications for liquid treatments. And his daughter actually came, and she's been in the industry. She's got her own company. Came to your trade exhibition over in Europe. When we first turned up, the Kiwis arrived in Europe, and I think Mrs. Bearson was looking at you going, who are these guys?
Yeah, we got grilled for 20 minutes on what we're doing over here. And then at the end of it, she said that it's the most innovative thing that she's seen at that trade show in 20 years.
And it's a sort of similar story with Xylem, is that I remember you saying, Matt, the Australasian guy in charge of disinfection. Xylem's one of the world's, it's probably the world's biggest water company, and they do UV systems, of course. And he came over and he just stared at the device when we first showed it at Expo in Australia.
Yeah, well, as you would have seen in those videos, there's a lot of science in behind it. But when you look at it, it's a really simple sort of approach that we're doing, just making it thin so we can get more light penetration in. And so, especially from Xylem, they've been standing just outside our booth looking at this expo unit with water flying through it. And you said, why didn't we think of that? That's so simple. And it's just one of those things where they've been doing the same thing for decades, and takes that novel step to really find something new to approach new markets.
And I think a really nice follow-up on that, which is something I sort of alluded to before, is that we were attending a workshop to operators in Australia, and Xylem were presenting there, and they were basically throwing you softballs across.
Yeah. So everyone's quite open that they cannot do low clarity liquids. So when they get down to that 30% sort of number, 40% number, they really just start walking away. They can't treat that liquid. And so when we were at this workshop, they were explaining the limitations of UV systems. And whenever the UVT got down too low, they say, well, that's where you got to go talk to Novolabs, or if the solids got too high, you got to go talk to Novolabs. Everyone's very open with where their current limitations are, and we really address that gap in the market that no one else can do.
Yeah, so we're really excited. It sounds all big calls, right? But we're really excited. We do really have something special, and I think I've said this to people before, is that to give you full details of technology, full details of our business and its potential, and from different markets that we're going to open up with us, it would take a lot of time. But I have actually done it. I wrote it on a very thick application and put it into something called the New Zealand High Tech Awards. So the High Tech Awards is quite a sort of big event held every year, where some of New Zealand's very top tech companies turn up, like Rocket Labs turned up. They won one of the most prestigious prizes on that night. There were 270 entries from New Zealand's top tech companies. And there was this little company here from Manawatu, which no one had really heard about before that. We turned up, we took more awards away than any other New Zealand company that year. And we've just also been awarded Tech Spin Out of the Year for Australasia. So, and again, it just gives us some confidence. It gives us a good benchmark that other people are looking at it critically, and it's kind of like a peer review, I guess. So coming back to this key thing, and we're starting to get towards dairy and beverages here. I can see those on the left, right-hand side. But what I'm trying to say here is 100% clear drinking water. Yep, that's over there. And there's great companies in the market who can offer solutions to that, and also very highly treated effluents. No problem at all. And it's not really, we've got no interest in going and competing there. We've got other work to do, more on the right-hand side. So as the clarity of effluents gets less, and that, like for example, that one second from varieties at one of our real clients' trials that we were conducting it on, that's some liquid coming out, whether it's processed liquids that's been what you want to reuse internally, industrial effluents, or whether it's some sort of, meat brine or whey or coconut milk. There's so many potential applications because we've got this technology which we can just penetrate these low transmittive fluids effectively with UV. And if you can do it with UV, that's generally a really, really good option. Okay, so this is what this unit here, we can containerize it. You can see going back to this concept of modules. We saw Mark with one before. I think if I push this button, we might see him again walking into the screen, pulling one open. Again, we're all about being able to treat lower clarity liquids, but we actually, our design offers a whole other bunch of features that it's just really, really easy to maintain. First of all, the lamps aren't in the liquids, so they don't foul up. But when you do want to, we recommend people give it a wipe down every week to start with, and then they can just take it from there. Some feedback is it's kind of, I think one of the operators said easy as to operate, so we're quite proud of that. But this whole idea is it's very radically different to anything you'll see on the market. It's basically, slide in and out of the rack, and it's kind of like, I think it's really quite a big step forward, because it's like in the old days you wouldn't have. If you're going to build if Google's going to wants a really big computer, they don't build one big computer. They take a whole lot of servers and they rack them up, and it gives you just a ton of advantages. So I'll just keep pushing on. We don't want to see Mark opening and closing that all day. So just some specs. Starting at the minimum, that's actually one of our small units. It's a single module which we just shipped out recently to a client. One module can do up to 570 cubic meters a day, which is 6.7 liters per second. It's a bit easier to visualize. We can drop that down. There are 2 channels in it, so we can drop it down and operate one channel at a time and have the other channel as a backup. And we could probably bring that down. I thought, Matt, around about 60 litres per minute. That's about a litre per second. We probably go a little bit lower, but we just don't want to go into what's called the laminar range. It's always better if the liquid's turbulent. At the other end of the spectrum, we can fire these things up. We're shipping modules, 10 modules in one container, which would do 5,700 cubic meters a day, or almost 6 million litres a day. We use standard lamps. There's no secret, special, unusual components. It's standard gear. We're bringing it in from the likes of Philips, and they'll run for 1.5 years if they were running full time. So they're very robust and high quality equipment. So on the big scale, that's kind of, we'd ship one of those that would do an entire factory, depending on the size. Got lots of features which I won't go into today. Or we could have, right back to that single module unit. In fact, we've even got another one, which is single channel. It's kind of R&D. I'll show you that one later. There's a bunch of benefits. I talked about computing industry and building like a server rack. A really nice thing too is that we run our flow through in parallel. So it's parallel processing of the liquids. Again, kind of like stolen from the IT industry, totally different to the existing UV systems, which tend to just put it all through one big unit, which means if you have one lamp goes down, you start losing capability. And you've either got to rush to turn it off and fix it, or you will have to suffer a lower treatment performance. With our system, if any one of those modules has a lamp go out, it automatically senses, it'll bring another one on automatically. It'll take one off, jog another one on. It also means that if you've got very low flow, we can run one module at a time, or we can run all of them flat out. These things can be open and worked on while the rest of it runs. And those are all basic advantages over legacy systems. Let's get on to look at some case studies now. That's the last one we shipped, I think, Matt. So that's gone down to Cypher. Are we allowed to say?
Yeah, so there's news articles on it.
Yeah, so there's news articles. That's Alliance Meatworks down in Matara. Fully installed. Now, do you remember the UVTs I was talking about? I was saying the legacy guys, they tend to bail out once they get to 30–40%. This is a UVT of only 13%. Reasonably high solids too. We've done worse than that, but that would also, I think that would also be a aspect.
Normally the limit's 40.
40. In this case, for microbe they wanted killed was E. coli. To meet resource consent conditions, they were coming off something called a dissolved air flotation system. Don't have to worry about that, but I'm guessing some of you will know it. Comes out of that into our system, averaging around about 7 million microbes. If we just don't worry about the units, it's colony forming units per 100 mils, but around about 7 million. Had to get that down to below 1,000, and in actual fact, we're getting it down to 55. So that's 7 million on average down to 55 in a liquid which is considered untreatable by UV. So we'll pick up some questions at the end. So this that system's doing currently about 9,000 cubic meters a day. That's another one, which is food and veggie processing. And as you can see, again, it's a wastewater application. You can see it looks kind of like pumpkin soup or tomato soup with some of the stuff that we've had to treat. Look at the UVT. We're now getting down to less than 1%, and we still were able to we trialed this very, very carefully. It was one of our first sales. And we managed to achieve a removal of enterococci, another one of those indicator organisms. 5-log removal, 99.99%. Last case study here, just back to another meat processing plant. I thought that was probably more relevant than wastewater plants, but this one, its maximum UVT just 0.3. So there you go. It's 100 times lower in terms of UVT than where the other guys go. We can't, no, we're at our absolute limit. And again, feedback we're getting is easily reaching consent. In fact, I think this is for site where the operator said, yeah, it's easy as mate. Yeah, which we kind of stuck in our head. I'm like, right, sorry, always repeating it. But also look at the colour. It starts literally starting to look like a food product. Well, I guess it is. It's just some of it's gone to waste. So we're getting to our last slides now, and really what we just sort of wanted to discuss here, and I wanted to show you, is that we have a new technology. Now, where Nova Labs is at is that we've established ourselves. We're now pushing the technology offshore, but we're also looking at a big period of quite intense R&D as we open up new markets, which is why I'd love to, if you have anything that you're interested in, please feel free to contact me, because we're sort of looking for somebody who's got a good problem, one which we can really knock out of the park, and as a starting point, because it's just such a big market. Where do you start? So as I mentioned before, we've as far as discharge consents for microbial control, we've got 2 billion litres already treated, but we can treat a whole range of things, bacteria, spores, yeasts, molds. We can do it for different reasons, like extension of shelf life, just preserving a product longer, or not necessarily for an environmental regulation, but just also where there's problematic animal or plant microbes that you need dealing with. And that's why I brought that picture there up. That's actually a trial unit or high-grade food quality stainless steel that we did where we were treating milk, and then that one was tested on farm. It's actually still down there in Canterbury, where the guy basically wanted better animal health, and he said, can you give me something, please? There is pasteurization systems for milk. They are a bit problematic because one, that batch system, so they've got a bit of work, and they tend to catch. That's just the feedback we've got. So he was looking, can we bring UV to the party on this? So we conducted trials. Now, with milk and hard to treat super low UVTs, all the examples I've given you up to now are all single pass, so it comes in one end, less than a second it achieved that treatment. Something like milk, it does need multiple hits, so we can recirculate it through there. And on that system, all that we did, which is good for food and beverages because it's not massive factory flow rates, it's more like tanks. And at this particular farm, there'll be a vat, he'll fill it up for his calves. In the evening, push the button, just goes round and round our device. And in the morning, we've achieved about a 99.9% E. coli is what we are measuring. The other thing too is that you can use light for killing all sorts of microbes, that you can also use it for reactions like photo degradation reactions. Or you could use it for curing. One example of photo degradation was we did some work with penicillins. And it's all different penicillins, but some of them are super susceptible to UV light. So there's actually potential to remove different chemical compounds by photo degradation as well. So new market opportunities, we're almost pretty much towards the end now, but it's just sort of looking at the range. We've had people talk to us about horticultural systems, where you've got a hydroponic type liquid, which you want to recirculate around, but you're starting to get stuff which is attacking the plant roots, some sort of pathogen, plant pathogen. We've talked to people about fish farming, of all things. Just as a wash waters, treatment of wash waters or conveyance waters, which want to be recycled within a plant to reduce your water footprint. Blood plasma was brought up by one of the meat industry clients we've been talking to. Could be byproducts like that blood plasma or whey, but also, I've got a little picture there of cold pressed juices, which really took off when people started using high pressure processing. But and I'm not saying that I can don't sell you a unit today and guarantee it, but we have done work when I was at Massey. Like we had an honours student working on apple juice, and with recirculations, he was getting, he actually got a 7. I just was looking up the format, make sure I got that right. We spiked it with some E. coli. It wouldn't be what you'd be worried about, but just to have something to kill, we spiked it up with that, and he got a 7-log kill in that system with recycling it through. So it's all possible. Things like coconut water, I was just measuring some of that the other day. That's a 6% UVT, and as you guys saw before, although that's a beverage, we've treated much, much harder liquids in a single pass to perform. So that kind of concludes us, and really why we wanted to show you that is we'd just like to make you aware that this is just a patented new approach to putting UV light into liquid. Essentially, it's just a different way of applying for light into a liquid, but it works extremely well. So that kind of wraps us up. I'll be open to any questions or discussions or ideas, feedback.
Great, thanks for that, Andy. It's
Sure.
yeah, really interesting to hear what you've been done, and it sounds so simple, and people are just like, oh, how did we not think of this before? So I've got I've got a couple of questions already. So one is, what type of pathogen inactivation certifications or challenge testing has been done? Because you mentioned previously in some of the other stuff that you did, 99.99% destruction of the enterococci.
Yes, so that's a really good question. It's one we get asked a lot. So we have a mass of data already. All our work gets done. Like, generally today we will send everything off to certified labs. One thing that we offer people too is that we have mobile devices where we go, this is a new technology. Look, bring it to your site, plug it in, run the results off to your site, be certain that you're getting the kill, because the trouble with certifications is they are specific to a particular type of wastewater, and it depends on dissolved solids, it depends on the form of solids, because even if we say it's 40%, you could have something like just 40 mg per litre of suspended solids, which is easier to treat than something which is 100 mg per litre of suspended solids, because of the way the microbes embed themselves in those solids. So there's nothing better than just bring it, test it. It's kind of like take it for a test drive. In terms of certification, it's funny, we keep talking about that. Much earlier on, certification really is most relevant to drinking water, where you've got 100% UVT, typically, New Zealand drinking water standards that know your microbes. So anything is possible. We haven't done formal certification yet, simply because it's actually relatively straightforward to just start that. But we've only just taken on a new R&D engineer this year, and through that we were looking at a whole lot of different options. So no, we haven't got one certified. formally, but that is actually quite a simple step through process that can be definitely done. Most important is that we'd say come test it, take it to your site, or we even have a caravan. We have a module about to ship, which will go off to different, can be transported on the back of a truck, or we can even look at doing smaller ones which go inside a factory. And I think that's the thing which is really, that's the best possible thing. So next question.
So kind of just coming back to that drinking water thing, which I think you might have answered. Someone asked, do you intend to get the units rated for use in New Zealand so that they could be compliant with the drinking water quality assurance rules?
Yeah, so we will definitely be doing that, and partly it's because people often say, is it certified? So it would be an easy thing for us to say, yes, it is certified for drinking water. But as I say, as soon as you go into all different ranges of UBTs and different microbes, but also different types of solids, you do have to be careful with what certification really means. Essentially the answer is yes to that. This will be done, and we would expect to have that done this year.
Great, thank you. I've got a question from Beth Mitchell. Hi, Beth. Do you think that the system could work on honey? I know that we'd spoken last time we talked about this. We were talking about high viscosity stuff, but obviously honey is very viscous.
Yeah, so it's funny actually. I had a friend who was the CTO of one of New Zealand's large honey companies, and we were talking about this. And then the question is as well, and I'm sorry, I'm not really an expert on honey, but the viscosity, it obviously becomes more viscous as it, so it becomes, it's easier to flow when it's warm. So it would simply, we could figure that out very, very quickly. By if we had some honey, we can run it through a system. If we can warm it up and just see how easily it flows. One of the challenges is being that you want it to have, like when we did milk, I remember running milk through it and looking at it and going, it looks different to water. Why is that? And then of course, hang on, we have to think the viscosity of milk is higher, and that affects the Reynolds number. And I mentioned before that it's ideally we want to stay in the turbulent zone. So as you can see in that photo there, it's very, very thin, but within that thin layer there's a massive amount of turbulent mixing going on. And that's important because it keeps bringing all the microbes up to the surface where they get the maximum kill. So yes, it is possible, but that's kind of like why we would like questions. If this could be really useful, it'd be something that we could look into. But one of the challenges we've got is just looking out of this massive market. There's so many things we could do. We've done some work on juices. We've done some work on milk, for example. But yeah, we could be here all day long just. So we really would love to find a good problem where somebody goes, this is driving us mad. If you guys could solve it, it would be really useful. Something juicy that we can get our teeth into, basically.
Great, thanks. So on the the juices and the milks that you just mentioned, have you performed any sensory studies when looking at the shelf life extension of products like those? Are oxidative off flavors an issue?
We did some, when we were doing juices, we ran some juices and beers and stuff through. That was our, there's a big disclaimer on that. Was a 4th year research project, or honours project. It was not a formal sensory survey at all. But there's some liquids which will be more effective than others. Beer is the classic, which is why you put it in a brown container. It's not to say that it can't be done, and if we go into a little bit more technical detail, what sometimes is happening, so if you look at the spectrum that our lamps are putting out there, we'd like 254 nanometers, but there's little blips of other wavelength coming out as well. So the trick there is to go, what is actually causing the reaction, which is creating any sensory problem? And then what you can do is put in filters. This is well known in the industry that you can put in filters and filter those out. And there's whole companies specializing. There's another really interesting company over in Scandinavia and I can't, Lyris, and you guys might want to look that one up. It's a much more expensive, lower throughput type system, but you'll see that all over milk, beverages, again with some use of filters. And I think I kind of half expected the question. So I was just having a quick look at some of the recent literature, and I see there was one. Like the European Commission had a thing where they were saying there's no nutrient disadvantages. There's Trends in Food Science Journal had a really good review article in 2020, and they were basically saying, look, what we like, and they basically said, this is all about the application of UV technology to milk. And they're going, well, what we like about it is it's low energy, so that helps with carbon footprint. It's that low maintenance that we were talking about before. It's actually relatively cheap to install compared to other things, and it avoids the negative effects of, or a lot of the negative effects of the heat. And they were saying, well, yeah, but it is effective for pathogenic and spoilage microorganisms, which is what I was sort of saying before. We have some evidence ourselves to show that it works quite well. But it's a key little quote that I took out of that paper was, when optimum conditions are applied, there is no impact on the physiochemical, nutritional, and sensory aspects. I kind of still would want to be fully convinced about that myself, because particularly with fats in milk, but that's, as I say, out of the peer-reviewed literature. And these whole companies specialising now in UV for milk, like that Scandinavian one. So it is possible.
Great, thank you. Got another
spores.
question here. So have you done much work on the ability of the system to kill bacterial spores specifically relevant to the food industry, such as Bacillus cereus, Geobacillus, Anoxibacillus, and Clostridial spores? Yeah,
so we've certainly done Bacillus cereus and Bacillus subtilis. And because part of the reason for that is we wanted something really, really hard to test. And we actually tested those in really difficult, like we put that into milk. You're taking an incredibly hard spore with a thick coating, and then you're putting it into something which has got terrible opaque, totally opaque. So don't expect to get results like you do for E. coli, but yes, we do get kills. And I think just going back to so undiluted apple juice, we tested that. I think I mentioned before, we got a 7-log removal of E. coli. And actually that was yeast, sorry, it might be mixing that up. On yeasts, it's just another microbe which just takes a much higher dose to kill, 2.5 log reduction of that. So I'm not going to promise, wouldn't be crazy to promise that you can get, total removal of all your spores in something like milk, but you do get reductions. And then it's a matter of really figuring out how much is needed, and what is viable, and which is why we're sort of kind of putting our hands up and saying, have you got a problem? Tell us about it. Again, going back to something like the coconut water. I'm sure that there's nobody out there with a huge coconut water market, but it's just a market which was taking off, and UV would kick it. We would absolutely knock it out of the park incredibly cheaply and simply, and that's why we're just going. We've got something new. It isn't. Some of these questions are hard to answer because it is why we're here. We'd like to go forward and do R&D to address them. And that's what I'd be asking, if you have something which you think, it's could potentially stop all that blood plasma going off when we're trying to transport it, or there's some other microbe that we're trying to control. Wonder if this would be useful. Please write to us, and we'd like to chat to you.
Great, that's it. I think, actually, no, I had a question. Does the liquid get circulated multiple times, or does that kind of depend on the volumes that you're working with?
Yeah, so all those case studies I have, I showed you where it was going down to, say, 0.3%. That was a single pass. And we need that really for large industries, because they've got, large amounts of liquid, thousands and thousands of cubic meters every day. When it comes to something like the example I gave you for milk, when he's feeding out a batch of milk to his calves, it works really well, because generally those things are harder to treat, but much, just different order of size in terms of how much volume. So he'll have a small tank, So with a small tank of milk, we'd recirculate that. And most food and beverages, well, again, coconut water wouldn't need it. So there'd be a bunch of things, a lot of processed liquids won't need it. But as it gets harder and harder, we can, what we can actually control, we can make it thinner, so we control our depth. We can control for lamps. So this particular one you're seeing at the bottom is 2 lamps. We have a single lamp, 2 lamps, and we actually just got some really nice new lamps in, which are even more powerful again. So we can control for power. Then of course we can control for flow rate, because if we turn for flow rate down, as long as we don't make it go laminar, we turn it down, it spends longer in the system, so it actually gets more light per litre treated. And then the last thing we can do is go, okay, well, if that wasn't enough, it's fine, we'll pick it up and put it through for a second smack, and recirculate it around a number of times. So that's kind of like the options we've got available.
Great, thanks. That's really helpful. I don't think we've got any more questions, but that was a really interesting discussion, and it's really great to hear from engineers about kind of practical approaches to food safety and other problems. So yes, I'll wrap up now. So as Andy mentioned, if you are interested in hearing something more specific to your industry, please contact him directly. And you can also keep me included as well. And we can look at how that how the food safety sensor might be able to help support any work that you're interested in. As usual, this has been recorded and will be available with previous webinars on our website under events, seminars. Again, please let us know if there's any other subjects that you'd like to hear about next year. So our next session in March will be advertised to you in the next couple of weeks, so keep an eye out, and we hope to see you next time. Have a great rest of your week. Ka kite anō.
See you guys.
Thank you.